The topic that we're addressing today is finding the dihedral angle between two faces of an object, and we're going to use two auxiliary views. The learning intentions for today's lesson are as follows. Apply previously covered content such as first auxiliaries. Interlink the use of the 3D model with the drafting question. Apply drafting techniques accurately in order to develop new concepts. Develop teamwork and social skills within the group work, class discussions. Create links and relate dihedral angle concepts within real life. So, this is a quick recap on first auxiliary projection. Individually, we will fill out the KWL chart, which will be reviewed at the end of the lesson. We will fill out the sections now of what we know and what we want to know, and then we will review at the end of the lesson what we have learned. We're going to look at dihedral angle now. What is a dihedral angle? Well, firstly, look around the room you are in right now and observe where one of the walls of the room meets the ceiling. We will see that angle. That is what we call our dihedral angle. So, a dihedral angle is the angle between two planes. So, how do we find this dihedral angle? Well, it can be found using two methods, auxiliary projection, which we're going to use today, or it can be found using rabattment. In order to find it, we have to first get the true length. After finding the true length, we get a point view. We look along this point view, and the dihedral angle is the true angle between two intersecting planes / surfaces. To obtain a point view of line, a view is projected to show the true length of the line. A subsequent view is then taken viewing along the true length, which will then give us our dihedral angle. This is another real life example of where dihedral angles are found. So the angle at the apex of your roof, the angle between the front of the roof and the back of the roof, that is our dihedral angle. This video just goes through the dihedral angle in the roof. So as we can see, as the house is rotated and we're looking at an in view of the house, the angle between the apex at the front and back gives us our dihedral angle. It is found only when both planes are seen as an edge view at the same time. All other views will give a fake or apparent impression of the angle. To see both planes / faces as an edge view, we must get a point view of a line that is common to both planes / faces. This is known as the line of intersection. The dihedral angle between two planes is seen in a view showing the plane / surfaces as an edge and the line of intersection as a point view. So now we're going to do this quick task, which is augmented reality, and we're going to use your devices. So in groups, we're going to find the dihedral angle between the yellow and green surfaces on the 3D physical model and the augmented reality digital model. So this is the augmented reality that you should have up on your screens. Now we're going to find the dihedral angle in the augmented reality. This is a 3D model of the solution in augmented reality. So as we can see, our second auxiliary is projected and we can see our dihedral angle between the two faces. So this is the drafting question we will be completing using second auxiliary projection. So the question is, find the dihedral angle between surfaces OAB and OAC, and it is to do with the tetrahedron. So the next few slides are just going to go through actually constructing the orthographic projection of a tetrahedron. What are the main considerations when drafting a tetrahedron? So you draw a plan view of the tetrahedron, which is an equilateral triangle with sides of 75 millimeters, and that's given to us in the question. So we project points from plan to in view at 45 degrees. And then we swing the true length from point B in the in view to hit the line where the arc intersects line O. That is equal to our point O. So we project the height from in view to elevation to complete the orthographic projection. And this is how we draw the tetrahedron. So think back to the start of this podcast where we had key points relating to first auxiliaries. Now we're going to take a first auxiliary. So what are the main considerations when drafting the first auxiliary? We draw x1, y1 parallel to OA to find the true length of it. So we're going to find the true length of OA. So project all points perpendicular to x1, y1. Project from the plan and take the heights from the elevation. Line OA is represented as a true length. This view is called an auxiliary elevation as it is projected from plan. So now we're going to go on to the next step, which is key learning from today's lesson. So what are the main considerations when drafting the second auxiliary? So we create an x2, y2 perpendicular to the true length, and we project all points parallel to the true length. This will then give us a point view looking along this line, which will then give us the dihedral angle. So we take all heights from the plan. The true length OA is projected as a point view. The angle between the two surfaces shown as edge view in the auxiliary plan. This is the question fully completed with all drafting lines removed. Your solution should look like this. So now, to conclude the lesson, we will now review our KWL chart on what we have learned.